So this is Chemistry 5.4, the foundation tier paper. The reactions between hydrogen and chloride to give hydrogen chloride can be represented by the following equation. The amount of energy released in making a bond is equal and opposite to that is needed to break the bond. Using the bond energy values in the table, calculate the relative energy needed to break all the bonds in the reactants. So these are your reactants. So the ones on this side are your reactants. An easy way to do it is every time you work out the energy for a bond, you cross it out. So the first bond we got here is hydrogen, so cross it out, and that is equal to 4.43. So that's one of the bonds you need. The other bond you need then is the chlorine bond. So again, cross it out because you've reused it, and that is equal to 242. And that in total, if you add them together, so the reactants needed, the energy needed to break the reactants is 678. The relative energy need given out when the bonds in the products are formed. So looking at the products then, so these are the products by here, what is formed in the reaction. Now this is a little bit different because you've got two of the same one. So cross one out, that would give you 431. Then you've got two of them, so it's 431 times by 2. You've got two of the bond again. That equals, if you do it in a calculator, 862. Using your answer from part A, state whether the reaction between hydrogen and chlorine is exothermic or endothermic. So you do reactants minus the products, and that equals minus 184 kilojoules. So the reaction is exothermic. Anything with a minus will give you an exothermic reaction. Moving on to question number 2, it's asking you to identify energy profile diagrams. So that one there is exothermic because there's more energy in the reactants than the products. And that one there is endothermic because there's more energy in the products than the reactants. So correctly label your energy profile diagrams, make sure you are doing that. Then it asks you to talk about activation energy, which is this hump here and that hump there. The minimum amount of what is meant by the term activation energy, the minimum amount of energy required for a reaction to occur. So the minimum amount of energy required for a reaction to take place. Moving down, then it asks you for 4 marks, nice 4 marks. Explain how the energy profiles are produced in terms of energy and bonds. So exothermic, more energy is required to break the reactant bonds than is required to form the products. Endothermic, then the other way around, more energy is required to form the bonds in the products than is needed to release, needed to break the reactant bonds. Question number 3 then is a graph style question, quite similar to another question we've seen on a different paper, a little bit different. So it asks you to plot the volume of acid, and they've given you the labelled axes against the temperature. Again, they've labelled it. 3 marks because they've labelled the axes. So plotting your points and trying to draw a curve. Maximum temperature arrived during the experiment, so you're looking at the minimum temperature and the maximum temperature and taking them away from each other, so that's 5.5, and the volume of acid needed to neutralise all the alkali, so that would be 50. So the volume of acid, thinking about it, drawing a line up, that's not a very good line, volume of acid would be 50, you're looking for the top mark there. Then you are looking at part C, which is a little bit like the science prac that you do. So it says, state how the amount of heat loss is reduced during the experiment. So how have they already reduced the heat loss? They've put it in a polystyrene cup and then in a beaker, so there's insulated it using the polystyrene cup. Suggest what else could be done to reduce heat loss if the experiment was repeated. So what is your inaccuracy? An inaccuracy in this one definitely would be to put a lid on this reaction, because we all know that hot gases rise, so add a lid to the cup. Choose from the box below the term that can be used to describe this reaction, exothermic, because heat is exiting the reaction. And then the 6 mark question on this kind of paper would be a really nice 6 mark question. It's pretty much similar to the first question that you did in terms of explain how bond energy values show the formation of hydrogen chloride is exothermic. So I've written out what you get each mark for, and I've talked about where you might get a mark. So the first thing I've done is worked out where your reactants are and where your products are. So reactants, what are the reactants? Again, remembering to get rid of the bond, so every time you do it. So the first one, hydrogen, is 436, so get rid of it, that by there. The second one then is 424, get rid of it by there, so cross them out as you go. That equals 6, 7, 8. Next thing you've got to do then is work out your products. So again, you've got two of the same one. One of them bonds equals that, so you've got two of them. So you're going to do 431 times 2, or add them together, and that gives you 862. Take them away from each other. Remember, it is reactants minus products, and that gives you 1 mark. Second mark in that section there for working out what it would be. And then a final mark for saying whether it be exothermic or endothermic. It is exothermic because the temperature increased, 1 mark. And then there's a final mark in this one for layout and organisation or spelling. Final question now is looking at the reaction of calcium oxide with water inside a tin can. So the diagram shows the cross section of a tin can. During the trial, the temperature reached 50 degrees, but the temperature is 70 degrees if it's heated properly. So suggest a change that can be made and explain how this would lead to the can reaching a higher temperature. Mix the calcium oxide and water before placing it in the can. The surface area isn't large enough for reaction. So if you can see, the calcium oxide is by here and the water's up here. So some of this calcium oxide will most probably take quite a while to reach the water to react. The second part of this question then, when a chemical reaction takes place, bonds are broken and new bonds are formed. Explain in terms of bond making and breaking why some reactions are exothermic. In an exothermic reaction, the overall temperature change is negative. More energy is released when breaking the bonds than is needed to form the new ones.